Hello friends, myself Muhammad my roll number is 27. Today I am going to talk about the gas hazards and this topic I am for the online refresher course in environmental studies and sustainable development organized by the UGC-HRDC Dr. Babasaheb Ambedkar Marathwada University of Aurangabad. This course duration from 19th September to 1st October. So friends, gas hydrants, what are these gas hydrants and why we need to talk about this? We already know the our efficiency or our dependency on fuel is increasing day by day, and the second thing is that natural resources for the fuel are very less and we using it day by day. So it's obvious they are not for the lifetime or always be there, and they are decreasing. Are we exploring it more and more? So we have to go with the alternatives for that. uh, and the gas hydrants are the playing the very important role for these purposes. So just I'm giving the I'm I'm bringing taking light on these gas hydrants. Okay, so what are the gas hydrants? These gas hydrants are also called methane hydrate, methane clathrate, gas clathrate, CH4 clathrate, and these gas hazards are formed when molecules of methane gas CH4 trapped by water molecules H2O in low temperature and high pressure. High pressure like hydrostatic pressure, which is present in the oceans most of the time. Okay, those are present on terrestrial side. We are going to talk about that, and by making this under with the low temperature and high pressure, these water molecules making cage-like polygonal structures such as that may be pentagonal and that hexagonal. These cases have to look like a dirty ice cubes, as I'm showing this on the this slide. Dirty ice cubes spread over a huge ocean bases or seabeds. Okay, that if we talk about the terrestrial side, these gas hazards or need permafrost condition means where the temperature below the freezing point of water, uh, 0 degree or 32 Fahrenheit for the longer period. It called the permafrost condition. Um, we will see it again. Okay, and the second condition is the when you talk about the ocean side, its needs seepages on the ocean bottom. We know there are many cracks, fractures, fissures are there. From is that opening allow methane gas from bottom of the sea to come out. Okay, below this ocean bottom, we know there with the depth, with increasing depth, the temperature is increases, and when on the bottom, when the magma chambers are from the mantle or upper side, means from the lithosphere, when the gases are released from the below, it came out, and most of the our area surface of the earth is covered by the oceans, so they go through these ocean bottoms now. So on that ocean bottom, especially where the marginal plates or margin area or terrestrial margin area, where the means say slope, continental slope, or shale, from where the temperature is low and the hydrostatic pressure also is there. Means that they go with the thermo line. Okay, ocean thermoline, but where the stable conditions means some conditions this low temperature and high hydrostatic pressure present on these places where these methane clathrate trapped by the water molecules and create huge amount of deposits of these methane gas or methane clathrate. In terms of okay, we'll see. Those are the just definition or little knowing about the gas hydrates. Now see how the little its journey or called the history. Uh, it is first documented in 1810 by Sir Humphrey Davy when he is experimenting with the chlorine gas in the cold water. So accidentally he found this means chlorine bubbling in the water molecules during his experiment. So he just mentioned that, okay. And in 1832, the first chemical formula of the cassette is given by the Michael Faraday, and he mentioned it is one methane gas contains 10 molecules of water, means 10 molecules of water linked and trap one gas or one molecule of the methane chloride or CH4. Now we know this methane chloride or linkage of this water molecule bonding may be from it may be 10 or maybe 7 to 10. According to that, its structure also changes. We will see it later. Okay, in my next slide. After that, in the 1930, when gas formation discovered by pipeline blockage during transmission of natural gas, mm, again means it's gas had means they accidentally discovered that means as per our geological concern, this gas was found in 1960 in the permafrost area of Mesoyaka gas field in Siberia. That on the terrestrial side, they are just means uh, correcting some leakages um, in the gas pipeline, and they suddenly found some ice cubes are just burning during their they catch the fire. They are those ice catch the fire and they just started burning. They seen that in the that time, and in 1970 confirmed that they also found in the marine environment by taking core samples. That also we see in our see in the next slide. Now, if you see, if you talk about the formation of the gas hydrates, how they form. So, by two, three way we can explain it how they form. By biogen, if you say biogenically, means the microorganisms, animals which are abundantly present in the oceans, they get settled down in the ocean bottoms, and when they get um, means create this CH4 release these CH4 gases, and then also called the some microorganisms. Those are called methanogens. Those are responsible for the production of the methane gas. They do this in the abiotic conditions. They are present in the ocean bottoms. They are also responsible for the releasing of this uh, CH4 gas. Or just before I told you, the thermogenically means where the temperature is low and pressure is high. These conditions also form the methane gas clathrate. Now here we can see the overall picture of that means from these cracks and fractures or faults, these gases are coming out, and some are settling at the bottom of the sea or some are just going with the going from the ocean water and releasing into the atmosphere. Some say here are the some microorganisms or sea animals which are also responsible for the settling of these methane gas clathrate, and these are also called the smokers or other seepages where the mud volcano or things erupted under the at the bottom of the sea, and just it releases these gases and other gases too in the ocean in the old ocean water. Uh, Now, see this structure just before I told you. These the molecules of, means number of the molecules from maybe 7 to 10 molecules. They create those linked with the CH4 molecules and make this pentagonal, simple pentagonal dodecahedral, hexagonal form, which are also called the structure 1, structure 2, or structure 3. But in this structure, they trap the molecule or CH4 molecule and make the methane clathrate. Now, how can we, or by which methods we can go, or by which way we can go to discover the look of these methane gas or gas hydrates on the sea bottoms? So there are bathymetry method, taking seabed temperature, calculating present deposits of sediments, calculating total carbon content, analyzing geophysical, geochemical, and core drilling samples. Now, bathymetry method means by going with your spare shapes, you can means send some sounds or waves through the ocean water, and they they touch the ocean bottoms and come back again, and that way you can measure the surface area and calculate that way. By calculating those waves you can say, or you can find the this gas reserves. And by the taking seabed temperatures means where you find the low temperature, you can go through, you can um, go with that, and you can means look for the when the temperature is go down, you look for the there are chances that those gas hydrates reserves are present there. Are calculating present deposits of sediments means where the where from the on the continental slopes where the turbide or the soil sediments come deposited or go down on the sea bottoms. On that area also you can you have chances to look out for the this gas hydrates report deposits, because when those also creating the lows and making a layer to not means not allowing the gas hydrates or methane gas to escaping out from the or from those load or that barrier that escaped below the sediments and just stay there. So there are also chances to find out the gas hydrates reserves, or taking that samples, or if you look if you take the samples from the sediments and experimenting that or analyzing that, that also give you a hint or clue there are gas hydrates reserves are there or not. Now, one also you can also go with the taking sample of the ocean water on the specific areas, or marking is by marking specific areas and count their total carbon content, and with that also you can go or look out for the uh, gas hydrates reserves. And by analyzing geophysical, geochemical, and coring drilling samples, these are the images means these are the bottom stimulating reflectors, or these are the ocean drilling program run with the all equipments or necessary uh, material they have for the equipments or instruments they have to go with these methods, uh, and these are the core samples taken from the ocean bottoms. Hmm? Uh, Go with the next slide, okay. See, if we talk about the occurrence of the gas hydrates worldwide, so these images show how much these blue lines are showing us how much the gas hydrates are present uh, on the ocean bottoms, and especially if you look out, these are only these areas marked around means these plates or continents, showing that these slope and continental shelf contain the large amount of the uh, gas hydrates reserves. And especially if we talk about the India, which I means worry about that thing, we have the three-sided ocean, or we have the peninsula type of mm, in our nation, or in our means land, terrestrial land, our land is peninsula, called the peninsula, which covered by the three-sided oceans. So this three-sided ocean, having the most probability, means after the sea is USA, it's a very large continental side having the large area of the on the seaside. But after this one this containing listed number one having the more reserve of the gas hydrates. But India, especially in Bay of Bengal and our Krishna Godavari basin, we have the world's second largest reserves of the gas hydrates. Means we have the more probability of the this means natural fuel, means future fuel of the if he utilizes it, means uh, and why we are need this, I will explain it later, okay. See the Bombay offshore, these numbers are in the metric gallons, okay, per cube metric gallons. I am showing this, okay. See here, before I just talked that see these mud or our deposits which making a barrier, means not allowing these gas hydrates or methane gas to go means release from there, and they just trapped and can also make good reservoir for the gas hydrates. Now, see, if you talk about the occurrence or distribution of these gas hydrates, here the blue lines are the more highlighted in the for the gas hydrates. Means in this Andaman Nicobar area, this Krishna Godavari basin, and this side our Bombay offshore area contains more and most of the gas hydrates reservoirs, which can be if we like these all things are under the experimental conditions or exploring conditions. Uh, that also we see in the next slide. Now, our Oil Industry Development Board, OIDB, Ministry of Petroleum and Natural Gas, our Government of India, runs the program called the National Gas Handler Program, NGHP, also known as the National Gas Handler Program or Expedition 1. Uh, that this National Gas Handler Program was initiated in 1997 with the steering committee and a technical committee of National Gas Hydrate program for implementing or initiating the program. Okay, based on the review of seismic data by the technical committee, two areas in Indian waters, one along east coast side and the other on west coast, have been identified as model laboratory area for further research and developmental work. Based on geophysical and geochemical data, just before I told you, National Gas Habitat Program identified four offshore areas for gas-headed coring or drilling operations. Dedicated operations were carried out in these areas during April 2006 to August 2006 through consortium consisting of Overseas Drilling Limited, Fugro, Macland Marine Geosciences, Geotech Limited, Lamont, Doherty, Earth Observatory, and scientists from numerous universities and national laboratories. These are the names. The National Gas Hydrate Program or our Ministry of Petroleum and Natural Gas means Oil and Industry Development Board tie up for the further exploration of the this gas hydrates. Um, what efforts National Gas Hydrate Program or India made in the Indian offshore has led to the, we see conducted comprehensive analysis of gas hydrate bearing marine sediments in both passive continental margin and marine accretionary wedge setting. Discovered gas hydrate in numerous complex geologic setting and collected an unprecedented number of gas hydrate cores, more than 2,800 meter from 21 sites and 39 holes. Delineated and sampled one of the richest marine gas hydrate accumulation yet discovered in the world in the Krishna Godavari basin. Discovered means this richest marine gas hydrate accumulation in the Krishna Godavari basin and the Bombay High on the Bombay High on around the Andaman Nicobar combinedly in our if you combine them, we are the world's second largest reservoir contains the gas hydrate reservoirs after the USA, Canada. After us, there are Japan and China also, but we are the second largest. Now, discover one of the thickest and deepest gas hydrate occurrences yet known, which reveal gas hydrate bearing volcanic ash layer as deep as 600 meters below the sea floor. Also, established the existence of a fully developed gas hydrate system in the Mahanadi basin of the Bay of Bengal. The Steering Committee of National Gas Hydrate Program approved the execution of National Gas Hydrate Program Expedition 2 in the 15th meeting held on the 7th October 2013 and at Ministry of Petroleum and Natural Gas correlation of well logs from National Gas Hydrate Program Expedition 1 and National Gas Hydrate Program Expedition 2 with seismic data for Area B is completed and currently work on Area C is in progress. Means from Bay of Bengal to Bombay, that's A B currently going on. Now, see the air pollution done by vehicles in our India. Now, let's talk about the we when we using the current fuel, natural fossil fuels means petrol. By that, the efficiency or means the releases of the carbon dioxide or other gases from this fuel is more or means more contains more carbon, and we have and the gas hydrates, those also means can be called as a fossil fuel, but its content less carbon content in its emission. CH4 also greenhouse gas, but when it's trapped or utilizes in the our as a second as a alternative fuel, uh, we also can reduce the percentage available in the uh, current availability in the environment. We can reduce it, but there are also chances when we utilize or we take out the reserve gas hydrates from the ocean bottoms. That means after that, that ocean bottom can also be get unstable. Means after that load can be dug it out or taken out from the ocean bottom. So ocean bottom maybe get unstable. But the other thing also, when the global warming and other issues are rising out, by those that hydrostatic pressure means melting of ice and increasing of temperature also can make just hit the gas hydrates and make them unstable, and maybe by that they just erupt or make the ocean bottoms are unstable. Means these conditions can trigger the methane clathrate itself to burn it out or come out, and they can just make the things unstable. Thank you.